Good evening, everyone. I had a couple of things which struck my mind today, and I thought I'd just share them here. It's a video blog. It's going to be a placeholder blog ultimately on my blog, where I put out a number of other research or material in this space. So the real interesting thing that I read some time ago recently was that when we sleep, apparently the cells that we have, the connections of the cells that we have in the brain, they're whittled away. It's one of the most fascinating things that I read, and apparently that's the main purpose of sleep. And the other was that there is the issue of toxic material that is created inside the brain during the day, which is again removed while sleeping. So this is, people have been trying to figure out what's the purpose of sleep, but this is a really interesting thing, and it seems to explain almost everything that we have, well, not almost everything, a lot of things that we have experienced in our daily life. And one of the first things I think we can start explaining is the way babies learn and what happens to their brain. And I'm sure that there is, and we can also then figure out what happens to the brains of people as they get older, and particularly what happens and what is, what causes Alzheimer's disease and so on and so forth. So I had this hypothesis that this would actually lead to Alzheimer's, and indeed there is research in that space which has come out recently. So let's look at the whole story, very interesting story. So a child is born with roughly 200 billion brain cells. Now the child's head is normally much bigger proportionately than any other part of his body compared to what it would be in the future. Now the brain is basically compressed inside the skull. We know that the child's skull is actually open-ended, and so it grows quite a bit, but it doesn't grow to the extent that other parts of the body grow, and then finally freezes at a particular level. But look at this thing, that in the first year, the child has got to kill off essentially 100 billion of its cells. So half its cells will die in the first year. And the brain is also growing. So guess what's happening here? I think it sort of becomes very obvious now that we think about what happens in sleep, and we link it with what happens to the infants who sleep a lot as well, is that their cells have completely no knowledge of anything. They're just like blank checks, blank slates. And so these cells are now accumulating knowledge of some sort during the day. They hear voices, they see things, they get the emotions and all that stuff. They have experience of food and other things or whatever, milk and so on. And the net result is that all that information that they're getting is building these new connections or these synapses. And so the neurons are now starting to produce lots of material. And in different parts of the brain, different stuff is happening at the same time. So this requires space, and I think the space is the really critical part of this whole thing that sort of makes sense now, the limitations of the brain space. So the cells that are potentially very active are essentially killing other cells that are inactive. So the space is a real big issue for the infant's brain. And I've quickly had a look at research which says that brains of the children grow extraordinarily rapidly during their first year and first few months. And that's what's going on. So they're collecting all this information, and the information is ultimately nothing but a chemical reaction, a chemical storage, which is built, and a biological unit. So it actually requires space. The space is not in the cell. The cell is very, like the neuron, etc. But it's basically the synapses, the length of the neuron. It's extending, it's connecting and linking with other neurons in different parts of the brain, etc. So the brain is actually growing. It's like a grass that's growing. Imagine grass that grows, fertile plants that are growing. The brain is like a plant, set of plants, a forest. Basically, the best way to think of it is a lush tropical forest inside your head. And the lush tropical forest has got these vines and creepers, everything connecting to each other. Now, this forest, unlike the forest in the jungle, has got space constraints. Even this jungle has space constraints, but this one has really serious space constraints. Now, the only way to do that is to kill the cells, number one, which is what happens in the early ages of the infant, or to actually, just somehow destroy the unnecessary material. So let's say you've learned something which is actually not very important or not relevant. You need to have a mechanism to destroy that, and that's where I think the sleep comes in. It's just a wonderful mechanism. Sleep also has the wonderful quality of actually embedding the memories, the important memories. All these are filtered through your amygdala and the processing that occurs during dreams, and that processing then finally leads to the embedding of certain memories, and that means those synapses are laid down, everything is properly organized, and then because that's occupying a lot of space, and during the day that's all that's happening, and during the night it's happening, the brain then has to work for a very long time to kill unnecessary material. And this idea of destroying, the material which is unnecessary is really a brilliant thing which has happened in recent science, and sort of explains why children are so good at learning languages. We sort of tell them anything and they absorb anything. The slightest, the language can have varieties of accents and varieties of way of saying things. And those ways are all learned very quickly by these little infants, because their brains are all absorbing it in a very big way, creating new neurons, really reconstructing the brain itself inside the head. It's like a forest of a particular sort. The forest of, a South Indian head inside the forest is quite a different kind of a forest than the one in Assamese, or because that has accumulated all that information. In addition, there's a cultural information and so on, emotional information and so on. So a lot of information that happens, plus the knowledge that we, scientific and other knowledge that we accumulate over the years. So all that stuff is now building this synapses. Now, because the amount of we live for a very long time. The brain finally reached the limit. So this is where the infant sleeps 18 hours a day to get rid of unnecessary information and keep more space ready for the future information. As your child becomes a teenager, then they're sleeping a bit less than 18 hours, but still quite a lot, like 10 or 12 hours sometimes. And that's again necessary for them to create the space, because what's going on, each time the brain reaches the limit of the head. Imagine the kind of sensation we get when we are sleepy and we actually haven't slept. What is the kind of sensation? It actually is very unpleasant. This unpleasant sensation turns out to be nothing but a physical sensation of stuff that is pressing inside our head. This is basically our own brain that's pressing inside. So if you don't sleep for many days, you get this horrible sensation of stuff that's inside your head and it's burning and pressing you. And that's because it's physical stuff and you're trying to squeeze it and it's getting squeezed. And the material is getting really tight and then it starts hurting in a sense. So it's actually physical pain. That's really interesting that I've sort of figured out from the studies. They know that that's what happens. And then you talk about the critical function of sleep, and I think now it's becoming more clear, and that's one of the things I had this hypothesis that, look, if this continues, then people who don't have good sleep should actually be the first to have Alzheimer's, because what's happening is that their old memories have been fully embedded, they're fully locked in, they've been emotional, amygdala has been applied, and the important ones are stored, the other ones have been decayed. Over time, for 20-30 years, they build good memories, but after some time, they're not able to build new memories because the brain is totally stuffed and it's not being cleaned out. The cleaning of the brain requires, I think, two things. One is the sleep, which I think is absolutely critical now that I see this whole exercise of how the brain works and how the human mind is actually limited by the skull capacity. But the other one that is there is the meditation. I think the meditation appears to be a plausible way to, number one, reduce the number of stimuli that's entering the brain. So there's a lot of stuff that enters our brain on a daily basis. By reducing that information, what we're doing through meditation, we are allowing the brain to settle down, and then in the meditation process as well, part of that processing is probably occurring in some way, because as the theta waves and others, the very calm waves of meditation come in, that mimics the waves in deep sleep. And that deep sleep waves are nothing but when the brain is finally at stable and is now able to sort and clean out things below the consciousness, because meditation, you don't even know what's going on. And this is all happening below the consciousness. You don't dream during meditation, right? It's not like the REM sleep, but it's pretty similar in many ways, as I suppose, and that's the kind of thing I'd like to study a bit more, whether meditation affects the brain in a similar way as sleep, which means that to prevent Alzheimer's, you would need to do two things. One is sleep very well. And that means getting rid of any sleep problems that people may have, sleep apnea, snoring, and all these things. And I have discovered that I have got a bit of snoring, which I'm trying to fix now. There's an app which actually measures that, and now I'm actually applying some, appliance for the mouth to push the jaw forward and prevent the snoring from coming to that extent. But that snoring is not the issue. The issue is really the issue of proper good sleep, and the good sleep is critical. The REM and other sleeps are important phases of sleep, so that you're cleaning out your brain. Every day morning you should feel really, really fresh, and if you're not feeling really, really fresh, that means your brain has accumulated toxins and rubbish and is also having this unnecessary growth of material which is preventing you from learning new things. So I think this is one of the most interesting things that I've discovered. I would like to obviously explore it much more in the coming days, and this is going to be part of a video blog that I'm going to start on this issue of understanding how our brain works. This has been, I think, one of the best things that I've read. The other one that sort of tells me as a result of this now I see is that brain might not be actually using quantum computing. Although there's a small, slim possibility, I had actually thought the brain uses quantum computing at some level, particularly to generate consciousness. I'm actually not quite sure anymore, because if this is such an extremely physical process, which it is now getting more and more clear, then we would probably say it's more similar to the ones that we have in the digital space. They're basically space requirements for the bytes that are being stored, the zeros and ones, etc. And how we actually store them in the brain will probably come out in the coming years. Okay, so that's probably the introduction to this topic, and more later. Thanks.